Specific heat a lot in our everyday lives. If you use a copper pan, they put copper on the bottom because it's such a good heat conductor, and so that allows us to heat our food up and boil water quicker and everything. So the definition of specific heat is the amount of heat that it takes to raise the temperature of 1 gram of whatever this is by exactly 1 degree C. Remember that calorie? That was a gram of water, 1 degree C. Specific heat is of other things. That is the amount of heat to raise the temperature of whatever that is, the copper or whatever, one gram of that by exactly 1 degree C. The SI unit is joules divided by grams times degrees C. The metric is going to be calories per gram degrees C. Now notice it's got 3 different units in it. Specific heat will allow you to cancel out units if you and the specific heat is not something that you're going to know. It's going to be some information that is known about a particular material, and that information will be given to you so you can use it to work problems. And so these are just some examples of specific heats. Notice water has a 2.03 specific heat as ice. Liquid water is 4.184 joules per gram degree C. In the metric system, it's 1.00. So everything is kind of compared to the specific heat of water. Notice water has a very high specific heat. That is that it allows it to absorb a lot of heat, and which is good for us in our bodies because it absorbs the heat that we produce when we're producing reactions and heat, and then it holds it and then allows us to maintain our temperature. So it's a very important concept. A couple of questions to think about. When water cools, what happens to the surrounding air? Does it cool, does it warm, or does it stay the same? We know water has a high, specific heat. Sand in the desert is hot in the day and cool at night. Sand must have either a high specific heat or a low specific heat. Decide what you think about those two. When water cools, the surrounding air warms. Remember that when you are moving heat, if you're going to have heat in one place, you've got to be removing heat from something else. So if you're cooling the water in the ocean, the heat is going from the ocean to the air, because the heat has to go somewhere, so you would warm the air. Sand in the desert is hot in the day, but then it cools off at night. So it's not hanging on to that heat. Therefore, it must have a low specific heat, that ability to hang on to the heat. When we're solving specific heat problems, you're going to be using that specific heat constant in order to get rid of units and to calculate things. You're going to be using the change in temperature. That's what this triangle stands for. That's a delta. Delta T means change in temperature. You're going to have a heat equation that we're going to rearrange, and then you're going to substitute any values that you know. So what is the specific heat of 24.8 grams of a metal that absorbs 275 joules of energy, and the temperature rises from 20.2 degrees C to 24.5 degrees C? Now, what are the units of specific heat? They are joules divided by grams and degrees C. So what that tells us is that joules will be on top, and we will divide by grams, which is 24.8 grams, and the change in temperature. The change in temperature is the 24.5 minus the 20.2. So see if you can calculate that and see what you get your answer, and then I'll show you how we work it. All right, welcome back. So you got 24.8 grams, 24.5 degrees C to 20.2. So I said the delta T, the change in temperature, is 24.5 degrees C minus 20.2 degrees C. For an overall change, we've decreased that temperature, what? 4.3 degrees C. Write the equation. Specific heat is joules over grams times degrees C. So we've got 275 joules divided by whatever the grams are, divided by also whatever the change in temperature was. And so 275 divided by 24.8 times 4.3, make sure you multiply those together before you divide them into 275. You should get 2.6 joules per gram degrees C. In the heat equation, what you're showing is how much heat you've gained or lost, and you use that specific heat. And so the heat equation is where we are going to calculate the energy or the heat in joules. And so if you're given grams and change in temperature, and you know the specific heat, you can get that from charts or tables, then you can calculate the amount of heat that you're going to gain or lose in a particular type of reaction or situation. All right, so for example, you have a layer of copper on a pan. You have 135 grams of this copper. How much heat in kilojoules, remember kilojoules is 1,000 joules, will raise the temperature of the copper from 26 degrees C to 328 degrees C if the specific heat is 0.385 joules over grams degrees C. Now, this is what you start with because this is what you can hold in your hand. This is what you have. You can measure this, 135 grams. You're going to start with that. You're going to have an amount of, you're going to have a delta T. Okay, the joules are going to equal the grams times the delta T times the specific heat. But the only other thing is, remember that it's asking you for what? Kilojoules. So you're going to have to do that final conversion from joules to kilojoules. Go ahead and try this. It's not as hard as it sounds. If you will cancel your units out right, it will not be that difficult. Okay, let's see how you did. All right, so this is what we have, 135 grams, this change in temperature, this change in temperature, and then your specific heat. We're looking for joules. Okay, so the first thing we do is we calculate what is this delta T, 328 to 26. Now we went from 26 to 328, so we gained heat, right? So our delta T is 302 degrees C. Our heat equation is grams times delta T times specific heat. Okay, your specific heat can be calories, it can be joules, or we can even convert that to kilojoules. So 135 grams times delta T, which is 302 degrees C, times your specific heat, which is joules, divided by grams degrees C. See how these units cancel out. Grams and degrees C cancel out. And then you would be left with joules, but we want kilojoules. So your final step will be joules and joules to cancel. And 1 kilojoule is equal to 1,000 joules. And when those joules cancel, you're left with 15.7 kilojoules. How many kilojoules are needed to raise the temperature of 325 grams of water from 15 degrees C to 77 degrees C? Okay, you know, or you can look up what the specific heat of water is. It's 4.184, right? 4.184 is joules over grams degrees C is the specific heat of water. 325 grams is the grams, and 77 minus 15 is the delta T. Use those numbers and see if you can calculate how many kilojoules it takes to raise the temperature of 325 grams of water from 15 degrees C to 77 degrees C. Try that and then come back. Okay, so we know what we're given. Our delta T is 62 degrees. That's 77 minus 15. We have grams and delta C. We have specific heat of water, which we know is 4.184. So we plug those in. And then we have to convert joules to kilojoules, just like the problem we had before. When we do that, we get 84.3 kilojoules. So the answer C is correct. So that's it for this section. If you feel like going on to section 2.6, come on. If not, you can stop, go eat a sandwich or something, and come back and see me later.